Here, so I'm going to shorten it because we're really just talking about mapping invasive species to prioritize treatment to inform the long-term recovery of biological resources on this particular creek. So when I did this project, I wasn't the natural resources supervisor for Jefferson County. It's a job I just took 3 weeks ago, actually about 2.5 weeks ago now. So I'm not doing this as an official representative of JCOS, but I am here to connect with folks about opportunities at JCOS. We do manage about 55,000 acres of land as an open space program, and there's more coming every year. So I'd love to talk with folks about that during the break if you have interest in partnering and working down in Jefferson County. So with that, Cache Creek is an 87-mile creek in north central California, and since we're not talking about Colorado, I just wanted to be explicit in the second slide. We are out in California, but I think this applies directly to all the good work that folks are doing out here as well. It originates in the coastal foothills and it flows to the Sacramento River, at least in good years, through a mosaic of canyons and forests, willow scrub, and various gravel washes. It's a very flashy creek. So this was earlier this year. Base flow is about 100 CFS. A week later, we're at 20,000 CFS. It went back down, bounced back to about 21 today. So we are in flood stage again today out in California. The Cape May Valley, where Cache Creek flows through, is a very rich agricultural area, and the creek is a very important part of that, as illustrated by the creek here on the sign as you enter the valley. These are all photos of signs I took during field work. It's a land with many uses and many rules. So the primary use is irrigated agriculture, as I've already mentioned, and they grow a lot of grapes and fruits and nuts and many other crops in this area. Most of the water is diverted at the Cape May Diversion Dam. It's the world's longest bladder dam. It's about 450 feet long, I think. And the water is delivered from the dam through a series of irrigation canals throughout the valley. This is the creek channel itself. There's also direct pumping by local farmers, a variety of highways and byways passing through the area. Utilities, both above and below ground, major transcontinental gas lines moving through here, as well as the usual above ground power lines. Some recreation and open space. They are in the process of developing a parkway with a lot more formal access routes and open space, but there is some existing areas. This is just north of the creek in one particular location. Some environmental education through the Cache Creek Conservancy, and this is an old gravel mining pit that's been reclaimed to a wetland. And a lot of activity and local involvement here at the Cache Creek Nature Preserve that's run by the Conservancy. Some riparian restoration, we're hoping more in the future. The main focus has been treating some of the weeds. I'll talk about it in here a little bit, but there is some restoration work underway and a lot more being planned for the future. Historically, one of the main land uses was aggregate mining. I'm told this is some of the finest aggregate in the country. That was used to actually rebuild San Francisco after the 1906 earthquake, and also used for the Golden Gate Bridge and many of the county roads. And it's apparently extremely high quality. Unfortunately, they're mining in the creek. So the entire creek channel used to be mined in many locations for gravel, and these are actually some historical photos. This is actually in the creek. This is just above the creek, and this is sort of one of the areas of the creek that was historically mined, a very graded, wide, gravelly area. This is from a photo in the 1996 Davis Enterprise newspaper. This is the creek. So it doesn't flow all year. It goes dry in the summer for a variety of reasons. This is an erodible bank. And this is the scale of mining activity that used to take place in the creek. It's pretty hard to believe. So in recognition of this, in 1996, due to a lot of local protesting and concerns over environmental issues, the county adopted what's called the Cache Creek Area Plan. It ended in-channel mining and created an off-channel mining framework, and it created a per-ton fee for aggregate. A lot of that money, and the scale that increases over time, is actually used to fund the conservation work now in the area. So it's a very creative compromise between many different land uses in a very complex landscape. And so far it appears to be working. So the overall area, the off-channel mining plan area is a broad, light gray, and then the interior portion is called the CCRMP, or the Cache Creek Resource Management Plan area. And it's composed of 7 reaches, and then the dam is at the upstream end. This is another area of the upstream reach. It's outside of some of the planning area, but still part of the spot because I did some mapping there as well. To implement the plan, it's very collaborative. There's 7 different mining operators, more than 45 private landowners, numerous county agencies, and also a local tribe, the Yochevedi Winton Nation. The plan created a framework for channel maintenance and bank protection, but also the long-term recovery of biological resources. So I'm one of 3 members that sit on the Cache Creek Technical Advisory Committee, and I'm the token biologist, I guess. And so for me, I'm responsible for what they call biological resources. But what does that actually mean? On this creek, it's the vegetation mosaic that I've already talked about, as well as over 200 different species of wildlife, birds, mammals, reptiles, amphibians, invertebrates, including 1 special status species, numerous fish, some of which were actually surveyed by Stillwater Sciences about 10 years ago, which is good to see Bruce here. And then, like I said, many special status species, not just the 1 insect, but I think over a dozen special status birds, raptors, at least one of the fish, I believe, is at least a species of concern. So there's a lot going on here. So these are just some photos I shot from the field to give you some context. These are 4 different views of what we call riparian forest along this area. This is a willow scrub area that you can see is increasing and may end up being at least some portion of it as a forest in the future. This is in the channel itself. Some of the upland areas are dominated by oak woodlands, some beautiful valley oaks with a largely non-native understory. These are open herbaceous communities, so the upper left is restored grassland, the upper right is a remnant, creeping wild variety grassland. This is a sedge meadow, and this is an open stand of bluefin in one of the areas. Just a view of the way that the willow scrub grades up into some of the oak woodlands and the upper vegetation on the upper slopes, as well as sort of the woodland or the marsh vegetation on the channel in the area where it is wet most of the year, and then some of the riparian forest in the background. So there's a real vegetation mosaic here. This is a map that I created last year when I reanalyzed the 2015 vegetation from LiDAR and aerial imagery. And you can see that on the upper end, don't worry about what the colors mean. Up here, there's some yellow and orange, and that's oak woodland and herbaceous area. Down here, there's much more wooded area. This is where the nature preserve is. And there's some dark green and some light green. It's an intermixture of riparian forest and dense scrub. This is where a lot of mining used to take place. There's very little vegetation actually on the landscape, even 20 years later. So it's not just vegetation, right? There's a wide variety of insects and snakes and western pond turtles and ash-footed flycatchers, cedar waxwings, red-tailed hawk. There's another one hiding up here with leaves, and some beaver activity as well. Well, we're here to talk about invasive species. So unfortunately, this creek was heavily invaded and remains so now. There's been a shift in species that I'll talk about here in a second. This is a perennial pepperweed field. Here's a tamarisk invasion in a former gravel mining pit off channel, and some classic California annual grasslands here. And there's a mix of pretty much everything in one of the messiest portions of the creek. So there is a history of invasive species control, and the original baseline planning studies back in 1995 noted that there was abundant arundo and tamarisk throughout this entire area. By 2001, there had been some state-funded efforts to start treating this. A&T, or just you'll see this throughout the presentation, it's just arundo and tamarisk. But most of the treatment efforts were focused on near the channel, where it was easy to get to, and where people could kind of pass through along the creek, on an annual basis. The treatments were conducted by the Conservancy and the county and the Flood Control and Water Conservation District, the USDA, ARS, and a lot of the private landowners. And they treated over 1,000 acres, which is a pretty monumental effort for these folks. They weren't quite prepared for a long-term landscape level weed treatment program. And there's been some more recent treatment of Urbana grass, which if you're not familiar with that, it's like campus grass in its growth form and the way it interacts with the environment. And there had been some upstream treatment above the dam by the local RCD and the Bureau of Land Management. So this is what it used to look like. This is tamarisk in bloom, I think, in the late 1990s within the planting area, just to illustrate how much of that was actually out there. Just some old photos of treatment. Nice tamarisk wall here, great wall of tamarisk, and then some mechanical control of arundo. And if you're not familiar with arundo, it's a giant reed, it's like a bamboo sort of plant, and likes to grow intermixed with tamarisk. So when they brought me on in 2015 to do some of this work, we had really reached an impasse. They had treated as much of the large stands as they could possibly get to. I mean, all the big ones had been treated, but there was continual recruitment from the small stands and the inaccessible pieces of property, like where landowners didn't want folks to come on and treat. And there's also continuous dispersal over the dam from upstream source populations, which, as you'll see, are significant. Meanwhile, there's a whole host of other non-native and invasive species entering this area and spreading. They weren't conducting spatially explicit weed monitoring, so no GIS or GPS. They're just kind of going through and spraying what they could see. And there was no sort of landscape scale prioritization of where they invest the limited conservation dollars that were available to treat weeds. They also weren't really planting native species after treatment, right? Sort of assuming that the passive restoration approach would work, and in some cases, yes, in a lot of cases, no. So they recognized these challenges, and the goal was to enhance the program with the projects I'll spend the rest of the talk describing. There were 2 projects initiated in 2016 by the county and the Conservancy and also the Resource Conservation District. The goal was to assess the abundance and distribution of a large suite of non-native and invasive species. Along the original 14 river miles of that planting area I showed earlier, it's about 2,240 acres, as well as starting to look upstream above the dam. So we added another 5-mile stretch of river and about 300 additional acres above the dam. So I'll kind of fly through these because a lot of us are doing weed mapping and we know what the objectives are here, right? In this particular area, we wanted to see how much of the Arundo and Urbana grass and tamarisk had actually been treated over the last 14 years, and I believe multi-million dollars of coordinated funding. Also look at the Arundo, Urbana grass and tamarisk upstream above the dam, and whatever other non-native and invasive species folks wanted to include in the mapping effort. We will also want to produce a spatially explicit baseline to inform adaptive management decisions moving forward, to engage landowners and a wide variety of other stakeholders in all these efforts to build awareness of weeds and support for future treatment. And for me personally, avoid rattlesnakes, poison oak, wild pigs, lightning, hail, and guard donkeys, all of which I actually encountered out there. This is a story for perhaps the beer at the social later. Okay, so in this kind of landscape where most of the land is privately owned, engaging the landowners is clearly important, right? And we take that seriously out there. I say out there, I live in Golden, I work here now, but my mind is still thinking about this project because it was important to me that we were able to do a lot of good work. All the landowners were contacted prior to the project. I built a fact sheet, distributed it to them. I called them, I went to their farms, I met them face to face, and we kept talking to them throughout this project, which is really important. How do we choose our species? Well, I call these the big 3. This is what the county has been focusing on for the last 14 years. I added all of these based on what I saw in the field. Some of these will be familiar to you, some of these not. I've coded them. The green ones are herbaceous, the brown are woody. The classic California eucalyptus, non-native blackberry, a really nasty and invasive annual grass. We all know about pepperweed. I know there's poison hemlock out here, and there's the purple loosestrife. Kind of lump these thistles because they tended to grow together. Nasty tree athena, tree tobacco, yellow flag iris, and yellow star thistle. And then I added 5 more once I actually found them in the field, and just added them into the database and kept mapping. The actual bamboo, teasel, fan palm, oleander, and the actual campus grass. So we had a whole host of nasty characters present in this watershed. I mean, the survey was pretty straightforward, right? I went out and I mapped all the weeds. Okay, so that's the real method here. I started off with the 14 river miles and the 2,200 acres of the main planting area, and then I went upstream in the fall. I conducted everything on foot, so I mapped comprehensively the entire area. And I also got to do some of it by kayak, because there were actually too many weeds to get down to the water's edge and actually map them in some places, which was both kind of depressing and fun at the same time. One thing I wanted to share was I used a mobile mapping platform called Amigo Cloud. Think of it as a cloud-based alternative to ArcGIS Collector, a little cheaper, really good for teams of people out mapping weeds. I mounted it onto an iPad. You could have used any tablet, but that was the software I used in the field to map the weeds. Mapped plants and patches, and then verified what I mapped using imagery from 2014 to 2016. So in the main resource planning area, I mapped everything in red and some additional county properties in blue. I found all 25 target species in this watershed, with a lot of variation between reaches. Very few large patches of those big 3 species, but tons of little plants and little patches. Lots of other abundant species, and I'll show some numbers here in a second, but edible fig, tree tobacco, tree heaven, and a whole host of herbaceous species. So lots of photos here. Here's our arch enemy recruiting in a side channel where they have traditionally not been spraying. There's a pepperweed hiding out to the side. This is in the actual channel itself. This one no doubt recruited coming in from upstream, I believe. Maybe it was bird distributed. But this channel is dry and Tamara's just pops up right in the middle of the stream bed. Some arundo regrowing where it was previously burned. Tree tobacco and a patch recruiting on a south channel slope. The largest mountain of blackberry I've ever seen, easily 30 feet tall, and probably 3 times as wide. Mount blackberry, the Himalayan blackberry, edible fig with the tree tobacco hiding in the background. Massive stand of tree of heaven, yellow flag iris with some non-native blackberry in the background. So we can go over the results, one-on-one if you're really curious, but basically the ones on the top are the most common. Thistles, perennial pepperweed, 55 acres of pepperweed, 54 acres of star thistle, 17 acres of blackberry. There's a lot of stuff out there. And even 10 acres of tamarisk, although a lot of it was scattered, like I said, into small patches. And then lesser amounts of some of these other species. These are what the data actually look like. This is what we call the Hungry Hollow Reach. It's one of those previously mined, gravelly, graded areas. The dots are red or arundo, blue or organic grass, and yellow or tamarisk. These are just individual points. And there's some size class data here that I'm not visualizing because you wouldn't be able to see it. But these are what the other species are out there in both points and patches, and it's a little hard to see here, but there's sort of scattered bits of this stuff through this reach. There's really not much vegetation there at all. However, downstream in the more forested area, these are all existing arundo, tamarisk, and rabbana grass that have been missed over the last 14 years. And there's some large patches even, it's a little hard to see here. When it comes to the other species, there's a wide variety of colors here, patches and individual plants scattered throughout this entire area. Okay, so in the upstream reach, I'm going to kind of fly through this, but did this exact same thing in a 300-acre area upstream. Found 11 of the 25 species. Huge stands of arundo, rabbana grass, and tamarisk. They've never done any treatment there. Almost 26% of the entire area was solid of these 3 species. The entire floodplain was often choked by in some areas. So a very pretty area. This is looking west, but here's your rabbana grass, and there's mixed stands of tamarisk, and there's a large arundo stand here. Massive arundo on the border of a farm field, just off the creek channel. Me staring into it, wondering what we're going to do here. Looking out over the creek, more arundo and tamarisk. The boat upstream with some tamarisk stands in the background, but also some great hills with a lot of native species. And then me on the boat actually mapping the mixed stands from the river. So there is an interaction between, I mentioned species come over the dam. This is the amount of arundo debris that came over in 1 year from an upstream flood. Some of this, no doubt, has led to the recruitment of new stands downstream. And here's the dam itself. 38 acres of tamarisk, 33 acres of arundo, lesser amounts of star thistle, hemlock, rabbana grass, and then far lesser amounts of some of these other species. This is what the data look like from upstream. It's just color everywhere, right? Because there's weeds, unbroken corridors of this stuff. Let's zoom into this area. This is what the data you can create in an Eagle Cloud actually look like. It would be very similar in our GIS collector. The hashed stands are a way that I use to indicate that multiple species were growing together. I just sort of estimated the relative percentages in the field, but you can see that there's a tremendous amount of arundo and tamarisk in this area. I want to throw these on to just emphasize that there is residual native biodiversity out there. So these are all native flowers. Some of the shots that I collected when I was in the field. Maybe some of these species are here or not, but blue-eyed grass, I believe an allium, blazing star, showy milkweed, owl's clover, and a few others here. So there is native diversity out there waiting to take off if we can just clean out a few more of these weeds. So they managed to reduce those big 3 extensively within the planting area, but the upstream populations are still there and they're extensive. Meanwhile, 20 other species have moved in and colonized like 95% of the understory and a lot of the other areas throughout this planting area. They're concentrated in the more heavily vegetated regions. Remote sensing is great. You would have missed most of what I mapped on foot. Many of these species were hiding under large trees, tucked away in nooks and crannies that are hard to see. And that's where this continual recruitment was coming from. So in this instance, ground mapping was essential. And I had to map everything because of the variation between the reaches. Subsampling was just not going to capture the full extent of the weeds. And like I said earlier, cloud-based mobile mapping solutions are great for teams, and I'm happy to talk with you about how that would work for your team if you wanted to maybe chat during lunch. How did this link to management? I basically said we've got to add some additional species to how we're prioritizing invasive weeds, right? So many of those that you saw earlier are now added to the list. Treatments are expanding throughout the planting area and also upstream. Now they're starting to use spatially explicit mapping. I'm training them how to use the software to go back out and follow up on the work that I did. When they remove biomass, or they should be removing biomass if they're not, and they should definitely be replanting the native species in most circumstances. And they need to expand their collaborations and try to find some additional funding, especially to get upstream. So with that, acknowledge the county, the local flood control, water conservation district, the conservancy, the tribe, the RCD, the makers of the Beagle Cloud, and Flow West, the consulting firm I work with on this project, and of course many of the local landowners. And since I'm here to represent Jefferson County Open Space, I just wanted to emphasize that now that I'm here in Colorado and working on 55,000 acres of land that the county owns and manages, I'm very interested in growing our natural resources program, and I'm actively looking for partners, applicants for our small grants program, potential consultants to work with. As many researchers as I can partner with, graduate students, undergrads, and professors, everything's on the table because I've been asked to try to expand our program, and I think we have a lot of great opportunities that I'd love to tackle about here. And with that, I'll take questions.
Yeah, I have a quick question. I was looking at Rayburn while you were doing has chocolate blackbirds on it. And fortunately or unfortunately, those little buggers like to hang out in the wind, blackberry, small patches. So if they have the other habitat conditions, which is good access to forage and open water, they will establish a colonial nesting colony. And did you know that